Hello friends, good evening. Okay, I hope all of you can see this problem clearly. Hello?
Yes.
Yes, sir.
Please solve this. I am taking you through simple problems to some high level problems. I mean, needs more skills. So you should be able to solve these problems as quickly as possible.
Yes.
Yes, sir.
Yes.
Yes. What about others? Hello. You should not take so much time. What is given here? The string is that moment of inertia of the disk is given here. So I is given. Everybody there, I don't know why you are taking so much time for this. I is given here. Okay. And then they are giving you the radius R, right? And then the force is given here, right? And then the time is given here. Okay, and what are they asking you? They are asking you the angular velocity omega. Okay. So, and they are told the string is wrapped and radius the wheel is free to initial wheel at rest. So omega naught is 0. So omega will be simply equal to alpha into t, and alpha will be equal to what? Tau by I. So tau by I into t, right? And what is tau here? Tau is force into radius into time divided by moment of inertia. So they are given all these quantities, just by giving that's it. Over. So force they have given on the moment, force they have given 20, radius they have given is 0.2, okay, and time they have given is 5 seconds, okay, and moment of inertia is 0.2. So this goes, it becomes 100 radians per second. That's it. Okay, so D is the option. Anil, you also got D?
Yes, sir.
Right? Okay. Fine. Hello, others, you have any questions? Shall I move on?
Yes, sir.
ನೀವು ಎಸ್ ಅಂತೀರ, ಉಳಿದವರು ಅದಿತಿ ಅನುಶ್ರೀ ಎಲ್ಲ ಎಸ್ ಅಂತೀರ ಅಂದ್ರೆ ಏನು ಅನ್ನವಲ್ವ ಎಲ್ಲ ಸೌರಭ ಪ್ರಭು ಅವ್ರಿಗೆ ಬಾಯಿ ಇಲ್ಲ ಏನಿಲ್ಲ ದೇವ್ರ ಗೊತ್ತು. So more angular acceleration. Don't take so much time. Angular acceleration is tau by I.
Yes.
So here tau is fixed. Okay, so tau is fixed. So angular acceleration is inversely proportional to moment of inertia.
Yes, sir.
Okay, so the case A. So alpha A upon alpha B is equal to IB upon IA. So alpha in the B case, in figure B. Okay. Figure B, the steel part is pivoted at O. Wood is there. So moment of inertia is less in B, isn't it? So here IB will be less than IA. Correct? So therefore, more acceleration, IB is less than this. So therefore, more acceleration in B. Correct?
Yes.
Huh? Hello?
Yes, sir. Yes.
Right. I think it is quite simple. So it's just to make sure that all of you get the right concepts. Whatever do this, you will, and if you have any difficulties, you immediately ask any theory to be repeated, I will repeat. This is mechanics. You should understand the mechanics. You should feel. ऐसा किया तो क्या होता है, ऐसा किया तो क्या होता है. Where are the forces? Where are the torques? Here there are two torques are acting. One torque for 10, and another torque for 9. They are both acting in one direction, and the other torque for 12 is acting in the opposite direction. So this will give you the net torque. Okay, this will give you the net torque, and then they are asking about angular acceleration. So the moment of inertia is same for all, and this gives you alpha. That's it. So tau for 10 Newton is 10 plus 10 into what is the radius R2? R2 is 30 centimeters. So 0.3 plus 9 into 0.3 minus how much? 12 into 0.04, 5 centimeters. Okay, so this divided by what is it? It is divided by P100. Okay, so if you see the options, so this all should come to some 51 something. So here it is 10 into 3, 3 plus 2.7, 5.7. So 5.7 minus 12 5 is 60. So 3 is 2.7, 5.7 minus 12 5 is 60.6 minus. So this gives you 5.1. So this gives you 5.1 upon 5100. That is 1 upon 51 upon this will give you 1 upon 1000. Right?
Yes, sir.
Now 1 upon 1000, that is 10 to the power of -3 radians per second. Okay? But why did you take so much time to do? I am wondering what is the problem? Hello? Hello, did you get it, all of you?
Yes, sir.
You have any doubts, questions?
No, sir.
Only you say no, others who have doubt are keeping quiet. First problem. You have handled similar problems many times. So what will be your strategy here?
So we will find first the moment of inertia, sir.
Moment of inertia is directly here. ml square by 3. ml square by 3 is the moment of inertia. But m here is varying.
Yes, sir.
Yes. So first you will find the moment of inertia. Then what will you find? First you will find the moment of inertia about O. Okay. Then what will you do?
Sir, then find the torque into
That's
gravity.
it. So regular. Then you have to find summation. Okay, you have to find the total torque, net torque you have to find. And then you have to divide torque by moment of inertia.
Yes,
So the thing is now finding the moment of inertia. Finding the moment of inertia is a big challenge. Challenge, is easy. So here is a standard process. You just follow the standard process. That's it. So you mark it here. Okay. So here you are marked. So what is this? This is going to be dx, and this is going to be dm here, right? And what will be the dm there? So the dm and from here you take this distance to be x, isn't it? You take this distance to be x. So dx and dm. So dm at that point will be, see, they are told here lambda naught x, right? At that point it is going to be lambda naught x. Is what? Is the linear density. Okay? So linear density into dx. This gives you dm at that point. Hello? Are you with me?
Yes, sir.
Yes. And therefore the moment of inertia here is simply going to be integration dm x square. Okay? And here this integration, and this integration will be from 0 to L. So therefore, of course, we are writing dm means it should be divided by m. You can convert it here. So this becomes 0 to L. dm itself is lambda naught x. So you will get here lambda naught x square plus x is x cube dx. Hello, correct?
Yes, sir.
Yes, sir.
So this one will be lambda naught L raised to 4 by 4. I know. Clear?
Yes.
Yes. Now find out torque. Similarly, torque. So the force at this point. What will be the force at this point? The force at this point will be dm into g.
DM.
That will be the force, and that force will be in the downward direction. Okay, into x. So therefore, you write here tau x. Tau x will be equal to dm into g into x. Okay, and just fill in the values for dm. Values for dm is again from here. So this becomes lambda naught. Okay, x is there, and already there is a x here. So this becomes x square g. Okay, this is lambda. This will be what? So I will have to take it as the tau x, the tau at that point x, and therefore the net tau. The total tau will be, of course, I should have written here dm into dx. I have forgotten dx. So integration of this. Okay, so integration of this, lambda naught g will come out, and integration of x square dx from 0 to L. So that gives you lambda naught g into x cubed by 3. So that is equal to, and the limit 0 to L, this will be equal to lambda naught g L cubed by 3.
Yes, sir.
Clear? Okay, so this divided by this, we have to just put it across. Okay, so if you put it across, so I think 4 by 3 is there. I think that is what you should get. So alpha will be equal to tau. What is it? Lambda naught g L cube by 3 divided by lambda naught L4 by 4. So this lambda naught will cancel, and L cube will go, this will go, and therefore we will be left with 4g by 3L. So C should be the option. Did you also get C option?
Yes, sir.
This is how we have to. Which is this problem? Problem number 31C. Okay. Right. Okay. I hope everybody got it. And such problems, now you know how to handle it. It looks humongous, but just just give a thought. Go to the basics and just handle it. Okay, friends. Shall I go ahead?
Yes, sir.
ನೀವು ಲಘು ಲಘು ಎಸ್ ಅಂದ್ರೆ ನಾನು ಲಘು ಲಘು ಮುಂದೆ ಹೋಗ್ತೀನಿ, ನಿಮ್ಗೆ ಜಾಸ್ತಿ ಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ.
Yes.
ಅದಕ್ಕೂ ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೆ ಹೇಳ್ತಾ ಎಸ್ ಅನ್ನಕ ನೋ ಅನ್ನಕ. Angular momentum. I hope all of you know the concept of angular momentum. You want me to tell something about angular momentum? I will tell if you want. If you want. Or if you have any questions, you can ask.
So we should best define angular momentum, please.
You tell clearly what you want. So angular momentum, I will write the mathematical form directly. L bar, okay, is equal to R bar cross P bar. Okay, this form you know. Basically, P bar. So basically, what it means? Well, you have a point mass, and this has got a P bar vector, momentum vector, and you are having some reference point here O, and then you have a position vector here R bar. Then the angular momentum of this about this O is defined as, so I should have to specify here O will be equal to R bar cross P bar. Okay? So you know that cross product opening and all, sin theta and all will come, etc. etc. You want to know something more, you can ask, I will explain. See, I don't want to waste your time and my time. You please understand, I am taking this class with the hope that all of you have very sincerely attended all the classes in the college. You have learned, you have understood this, you have solved very nice problems, and in addition to that, before attending my class, you have gone through NCERT book in detail, you have marked all the concepts in that, and if you had doubt, you would have sent the doubt to me. Since you have not sent any doubt, that means you have understood everything in NCERT. So with that belief, I am moving ahead. But in spite of that, if you have issues, you can ask. Okay, clear? This is all. See, angular momentum definition is this, and just like linear momentum, only linear momentum is this. Okay, and then again here. Okay, so here angular momentum. For linear momentum, we used to write here linear momentum T bar is equal to mvp. Okay, so here we are going to write L bar is equal to what? I into omega. Okay, hello? And then here for linear momentum, F bar is equal to dp bar, okay, by dt. So here we are going to write here tau bar is equal to dl bar by dt. That's the difference. So everything is similar. Angular momentum and these equations are similar. There you have got law of conservation of linear momentum. What does it say? What is conservation of linear momentum of a system? Come on, anybody? Come on. Nobody wants to define. Come on, man. Try. I will correct you. I know you will not tell. See, don't worry, yaar. See, you please, don't inhibit yourself. Don't try. Don't sit in my class to prove a point or to show that you are excellent or nothing. See, when I was of your age, I also did not know many things. Okay, it is accepted. You have to accept the truth. Nothing wrong. But when I am giving you an opportunity to tell, you tell. I can correct you. That's it. Okay, if you try, you will learn. What is conservation of linear momentum? ಈಗ ಅಡ್ವಾನ್ಸ್ ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ಟರೆ ಬೇಕಾದ್ರೆ ಮಾಡ್ತೀರಿ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಲೀನಿಯರ್ ಮೊಮೆಂಟಮ್ ಥಿಯರಿ ಹೇಳಿದ್ರೆ ಹೇಳಂಗಿಲ್ಲ only you see amongst all the students here, Abhinav, is a very brave boy, very good boy. He at least tries, and many times he has goofed and I have shouted at him, but still this boy is such a wonderful boy. He wants to learn. God bless him. I hope
sum of initial momenta of all the particles constituting the system is the same as the sum of all the final momenta of the particles constituting that system. Then we say that the linear momentum of the system is conserved.
Okay. If somebody correct him. He has missed out a very important concept here.
So the net force on the net external force on the system should be 0.
That is the most important thing. Okay, see, collectively you can also tell the definition, correct. So consider, see, always definitions, you must tell the condition. Consider system of particles, okay, and no external force is acting on the system of particles at any given instant of time. If the net momentum of the system or the total momentum of the system is something, then at any instant of time, the momentum of the system will remain same, although the momentum of the individual particles of the system can change in a time interval, but the sum total or the net momentum remains same. That means the momentum of the system is conserved. I hope you are able to make a physical picture of what I told, and that's it. Mr. Abhinav, the most important concept only you forgot. So this is how dunya is. So students can solve advanced level problems in collision using conservation of momentum, etc. But when it comes to what is conservation of momentum, well, most of the students cannot say so. Okay, so that is the tragedy of today's education system. Okay, anyways, please correct yourself. Right. So similarly for angular momentum, consider again system of particles. The angular momentum of the system of particles is conserved when there is no net external torque acting on the system. Simple. Okay. Anything more you want to know? Angular momentum? Hope not. Okay. Right. So Earth is a point mass of so and so revolving around Sun and distance so and so in time. Then the angular momentum of Earth around Sun. I think that should be quite simple. So if you can't comprehend this problem, you draw. You draw Mr. Sun. Okay, Mr. Sun, and then Mr. Earth. Right. So Earth will have P bar, and this is I bar. Right. So you just have to do that. Point mass is given, and the time duration is given. Okay, angular momentum. Okay, right. So you write the basic formula of angular momentum. Angular momentum will be what? I into omega, right? Or now you say you don't have to write L bar, so L is equal to I into omega. Hello, are you with me?
Yes.
What is I? M into R square. Okay, and what is omega here? Because the time is given here. So if time is given here, then you write it as 2 pi by t. Okay, this is angular momentum.
Yes.
So that's all. So they are given all the quantities. You just have to do that. So what is the point mass? See, now here how to solve this problem. Okay, so there is 6 here given, and what is R? Radius is 1.5. Okay, so this is 3 by 2 into 3 by 2 R square into 2 pi into time t. T is 3.14, that is same as correct now? Of course, into the powers of 10 you have to write. Okay, so pi's get cancelled, 2 will get cancelled, and 2 ones are 2, 3. So 3 cube will be 27. Something to do with 27. There is only one option. Okay, so just mark it.
Yes, sir.
This is the quickest way to solve the problem. Understood?
Yes, sir.
So that is how you have to save time. And these problems are, this data is usually given in such a manner that, if a student is smart, he will save the time. That's the whole. Okay, shall I proceed?
Yes, sir.
It's again a fundamental question. So this is a basic, this is testing your conceptual clarity on the concept of angular momentum. So if you have understood angular momentum, just by inspection you can tell it within 5 seconds.
Yes, sir.
Same at all the points along D, right? Which of them is not correct? Yes, somebody else also do that.
Oh, that's sir.
Ask.
Sir, we should take the angular momentum with respect to O, sir. Yes, sir.
So they are asking you which of the statements is not correct. Which is not correct? One student said some B. What about others? Aryan, what is your answer?
Option B. Option B.
B. So
Yes, sir.
two students are going for B. Two students are going for B. What about others? Others are simply sitting there.
Option B.
Option B. These students are going for option B. Arey yaar, what are they asking? Angular momentum. What is angular momentum? See here. L bar is equal to what? L bar is equal to what? R bar cross P bar.
Yes.
So this is R bar cross M V bar.
Yes.
Okay. This is M V R sin theta. Okay. What does this mean? This means MV into perpendicular distance from O. Understand? That is R perpendicular. That is, see, supposing you have a particle here which is going like this, velocity like this, mass of the particle is here. You are taking this as O. So what is the angular momentum of this about O? So you are taking this, isn't it? Hello? So then this is the theta, this becomes the theta, correct? Hello?
Yes.
So if that is theta, then what is it? That is theta, theta is in that direction. So R sin theta. So that means now if you take this, so this line and this line are parallel, this is theta, then R sin theta will be what? This perpendicular distance, isn't it? What is this? This is R sin theta now. Hello? Hello?
Yes.
Yes, sir.
So now whether the particle is here, or whether the particle is here, okay, whether the particle is here, it is going like this, okay, this line will be going like this, these lines will always be perpendicular and R will be changing. Hello?
Yes,
But and theta will also be changing, but R sin theta will remain same,
Yes.
isn't it? Hello?
Yes, sir. Yes.
So therefore, you just have to draw a line. See how to do this. See, this body is traveling like this. You just draw a line like this, and from here you take this perpendicular distance. As the body is traveling along this perpendicular distance will not change. So therefore, see, as far as the first condition is concerned, it is 0 when it is moving along A. When it is moving along A, obviously it is 0 because R bar cross that is 0. The angle between R bar and V bar vector is 0. So that first option is correct. First option is the right option. At the same time, all the points the same at all the points on D, correct? So D it is same because this perpendicular distance is always same. So this is also the right. Then of the same magnitude but opposite directed from B and D. That is, if you are looking at O, the angular, see this is also 1 meter, this is also 1 meter. The angular momentum of this with respect to this it has some magnitude. The angular momentum of this here has the same magnitude because M is 1 meter. But the angular momentum here is in one direction, here it is in the opposite direction. So this is also the right option. Increases as it moves along BC. No, it doesn't increase because as wherever it is moving, this perpendicular distance remains same. So therefore, it doesn't increase, it remains same. So this is the wrong option. So the right option here that you have to mark is D. So this is testing your angular momentum concept. Very clear. You have not studied and come to the class. As usual. See, this is again and again, in every class I am almost telling you, but I don't know for whatever reason this age group is like this. You have a belief that you sit in the class, the teacher will give sums and then he will solve and we will learn. We will not sit and put our effort and break our head. Okay, and unless you break your you involve your brain, you cannot get the knowledge. Okay, now you please, at least now I am hoping, every time I say my students hope, Nanodaya Agati, now from henceforth my students will change. That is my wish, but it doesn't happen. Anyways, shall I proceed? Any questions?
Yeah.
Arunappa, hingait nodu Jagat. So which law will be applicable here? Which law will be applicable?
Law of conservation of angular momentum.
Correct. So apply that. How we used to do with linear momentum, like that only you should do it. There also you used to do the momentum throughout remains same unless external force acts. What is, see, when this ball is just about to hit this, when this ball is just about to hit this, right? Just about to hit this. What is the angle with respect to this point? Isn't it? In rod, sorry, with respect to this middle point. With respect to this middle point. With respect to this middle point, this distance is L by D. Correct?
Sir.
And the mass of this is M. Mass of this is M, and it is moving with velocity V. So, what is the angular momentum of this just before it hits?
MV and
Yes, mv into L by 2. Correct now? This is the angular momentum of this, initial angular momentum of this. After collision, what is the angular momentum of the clay rod system?
it should be same.
It should be same. Common sense. Isn't it? It should be same. So, do you have the option? Yes, there is an option. Over.
Yes, sir.
वो पुट्टी आया उधर टक हो गया वो अलग सी प्रॉब्लम है. Okay, see the same problem you can use the same problem is asked in the advanced examination. Okay, so in the advanced examination, well, this goes and gets stuck, right? And then what happens? If this ball goes and hits that rod, then what are the consequences of this? What type of motion will be there? So what type of motion will be there after this goes and hits that? What type of motion will the rod get?
That will rotate, no?
Only rotate
Based on one translation.
and also translate.
That part, it will rotate and translate both.
Correct. It will rotate and translate.
Yes.
Okay, so the advanced level problem will be, well, so what is its, describe its motion. So you have to find out the translatory acceleration, okay, and also the rotational acceleration. That is the problem you are supposed to solve. You have all taken up IIT advanced, okay, you are supposed to solve that, the same question asked at that level. But now the same thing asked at the first level is this. Anyways, you train yourself well for mains, then you will get confidence. We'll train you for the advance. Right.
Sir, wonder, sir.
Hi, please.
Sir, for the translation, sir,
Ah.
should we consider conservative linear momentum?
Yes, yes.
Yes, yes.
You have to. Of course, bit involved, but that is how you will start the process.
Okay, yes.
Okay, obviously, no. Obviously, see, linear momentum. Only thing is, it is not. The line of action is not same. So it will come under oblique collision. Okay, it will come under oblique collision, etc., etc. We'll decide. We'll discuss that later. Okay, shall we proceed? So you see, student, that is the intensity that is necessary here. Okay, so I am not going into that because I know none of you are in that range as at present. So nothing wrong at this stage. If you accept that yes, you are not in that range and you have to excel in this range, you just excel in this range. We will go into that range. You still have time for it. Most important is your attitude must change. The sooner it changes, the better for everyone. If Earth were suddenly to contract to 1/10 of its present radius without any change, 1/10 height is a one-nth. So you can't comprehend the problem, you draw the Earth. So this was our Earth, beautiful Earth. So its radius is some r. Its mass is m.
Yes, sir.
Okay. Then its radius cylindrical. Then the new day will be. So new day means now our new Earth is going to shrink. Okay. So if you take any point here now, the same point will come here. But this will be the new radius. This radius will be r by m.
Yes.
So here again see, it has shrunk by itself, they have told, and then so no external force is acting. So here, and the momentum of the system is conserved. What is angular momentum? I1 omega 1 is equal to I2 omega 2. So we used to write no, m1 v1 is equal to m2 v2. Okay, similarly you are writing this. That's all. Okay, now they have also told about the timing. So therefore, just modify this equation and write it as I1 into 2 pi by t. T1 is equal to I2 into 2 pi by t2. So obviously these two will go. Okay, t2, right? And what will be I1 here? It is a sphere. So what is the momentum of inertia of a sphere along the axis? Inertia of a sphere about its axis passing through the center?
2 by 5 mass.
Excellent. So it will be 2 by 5 m r square by t1. This will be equal to 2 by 5 because mass has not changed. But r has now become r by l square, and this becomes t. Clear? Hello? So 2 by 2 cancel, m cancels, r square cancels. Okay. Now it is matter of t1 and t2. So here you want to find t2 here. So therefore t2 will be equal to t1 by n square. So T1 for Earth is 24 hours by n square hours. So do you have the option 24 by n square? Yes. C should be the option. That is C the option.
Yes.
So you see, don't worry. See, problems look like that, but just draw the diagram. It will give you an idea. So they are telling about the time. So just mark 2 points. So the number of rotations that we will do. Just keep writing the basic equations. See, mains, NEET examinations are all going to have questions which are testing this. And again, I repeat, if you have perfect understood, not see NCERT book ಓದ್ಬಿಟ್ರೆ ತಿಳಿದು ಬಿಡುವುದಿಲ್ಲ. Okay, if you read NCERT, if somebody teaches you NCERT book, take a write definition, solve sums. No, your effort to learn. See, the teacher teaches something, and then the next level he is making you to think. He asks you questions. If you respond, then the teacher will correct. So this process should continue. Then knowledge will keep growing like a plant in you. See, you cannot transplant a tree, right? You sow the seed and then you nourish it, it will grow. Like that, the knowledge has to grow. Okay, then it will be there with you forever, right? At least for the next couple of years, if not forever. Okay, shall I proceed?
Yes, sir.
You know radius of gyration now? If you don't know, you ask. I will tell you what is radius of gyration if you don't know. If you keep quiet, I think that all of you know, I cannot do anything. So again, what is conserved here? Angular momentum is conserved.
Yes.
So the basic equation will be same. I1 omega 1 is equal to I2 omega 2. Okay. Now they are asking you the radius. They have not given I1, I2. They are given only these two values. Omega 1, omega 2. They have given these values, and they are asking you radius of gyration. Correct? Okay. So I1. What will be the in terms of radius of gyration? What will be I1? It will be m1 k1 square.
Yes, sir.
Of a body they have told, so I will not take m1. Understand? Of a body they have told, so I will just take m k1 square omega 1 is equal to m k2 square omega in terms of radius of gyration. Okay? The ratio of the initial radius of gyration to final radius of gyration. So you can take k1 as initial. So here you have to get here k1 square by k2 square will be equal to omega 2 by omega 1 or k1 upon k2 will be equal to root of omega 2 by omega 1. So A is the option.
Yeah. Sir, can you explain what radius of gyration physically signifies?
I asked you before I start this. Do you want me to tell about radius of gyration? Okay. Now let me tell you. Physically, well, it has no meaning. Understand? But when you solve some interesting issues, okay. For example, now you want to say now in your NCERT book itself, you have got that this one now. Supposing there is a slope. So here you are keeping an object, okay, which is cylindrical in shape or spherical in shape, right? Hello, remember? Or a ring, disk. Okay, all of them are kept at the same height h. Okay, same mass m. I hope that illustration is given in your textbook.
Yes, yes.
Now, which one will reach Earth first? Will reach this point first? So, if you want to compare, okay, then you see the formulation of the mathematical formula here or the mathematical model will become simple if you are able to express the moment of inertia of each one of them in terms of this radius of gyration. Okay, see, for example, now for disk, for a ring, it is mr square. So, in terms of radius of gyration, it becomes mk square. And therefore, now what I have to find k is equal to r. Right? So, for a disk, it is mr square by 2. This is mk square. So, what does it imply? K is equal to what? Sorry, not square. K r by root 2. So, you can express the, see, when in the calculation, any moment of inertia will come, but you will write the moment of inertia in terms of the radius of gyration. Comparison becomes easy. That's it. That's all. Nothing more, nothing less. That is the physics.
With radius of gyration, how will you compare like?
You see that I told you. Did you read NCERT book? Did you go through that illustration? Sphere, cylinder, this one. You tell me frankly. Did you go through that?
Yes.
Then what can I do? You see, you want me to teach the theory, I will teach. See, I think I am in the 5th class now, and I am just in the 36th problem. So I am just telling all of you, you go through the book, underline what are the concepts there. Whatever you don't understand, send a mail to me. I will first teach you that whatever you have not understood, and then I will proceed. I have said so many times, I have sent mail to you, but you don't want to listen to me. That's my problem. Anyway, you go through the textbook today, you read that. If you still don't understand, exactly tell me which point, which line in the NCERT book you have not understood, I will explain. Why I am telling you like this, please understand. If I start teaching the theory, 1 hour will go on teaching radius of gyration. Understood? We don't have time. You understand, today is 15th October. Okay, I have just completed the 4th chapter. I should have completed the 6th chapter. So, whatever I have told will complete by November and all will not happen at this rate. So, if you also work, I can also work. And it will not take much time. My homework, it will hardly take half an hour, 1 hour. That full chapter, if you read properly, underline and come. But you don't want to do that much, means what can I do? And one more thing, if I teach radius of gyration, etc. also, it will be waste. Because your effort is not there. Only my effort will be there. Okay, so please understand now. You read and come. If you don't understand, next class I will explain. You tell me pinpointer, NCERT book, sir, this point, you first send a mail to me. Okay, sir, this paragraph I didn't understand, I will explain. I am sure if you put effort, you can understand. You are a smart boy. That is different. What is that? You solve advanced problems. You cannot comprehend the problem, you draw the diagram. So the table is a table using access. There is a block of x. So they have kept a block of ice. Very good. The system rotates with omega about the axis passing the center of the table. Ice melts on its core without evaporation. The speed of rotation. So what will be the total momentum of rotation? Total inertia? That will be inertia of the table plus inertia of block of ice.
Yes, sir.
Correct? This is the total. And it is rotating with certain this one. So what is the initial momentum? I total into omega 1
Yes.
will be the initial. Now, what they are told, ice will melt on its core without evaporation. That means the mass is not lost. The speed of rotation of the system. So now apply your brain. So here ice will melt. Okay, क्या होता है?
It will melt and spread over the
So that is important. It will melt and spread. Correct? So it will
Yes.
melt and spread. Okay. Then you see this is the total initial total at point 1. Now I total 2 will be what? I of table will be as it is. But now ice is in the form of water. So what happened to the moment of inertia now?
It depends on how it spreads.
How it is spread? वो टेबल घूम रहा है और ice is melting.
Come out, no?
Huh?
So it will go out, no?
So now there are two things. One is it will melt and spread. Okay, first it will melt and spread. Hello?
Yes.
So first it will melt and spread. Okay. Now ice is in the form of water. Okay, all over the table. So what happens? This moment of inertia of this one will be greater than this, isn't it?
Yes.
So therefore, I total now 2 will be greater than I total 1. Because water is spread, the moment of inertia will increase. Hello?
Yes, yes, correct.
And therefore, omega will decrease.
Yes, sir.
As the ice is melting, omega will start decreasing. Correct?
Yes, yes.
Omega will start decreasing. Okay. So omega will start decreasing, right? Accelerated table of the system. Omega will start decreasing. Now, as time proceeds, this due to centrifugal force, the water will start going towards the edge. That is what happens due to centrifugal force. And here the edge cannot support, it will start falling. Correct? And finally what happens? The omega, when all the water has fallen, okay, then when all the water has fallen, then the moment of inertia will only be that of the table. Hello?
Yes, sir.
So only moment of inertia will only be of the table, and that will be lesser than the total before. Okay, now you will get I total 3. This is without water. This will be less than I total 1. It will be less than that, and therefore omega will once again increase. Okay, so first it will decrease. So omega decreases to a value less than omega. Hello?
Yes, sir. They have asked about the initial case or?
That's right. If the ice melts on its own, the speed of the rotation of the system, what will happen to the speed? The speed will decrease. But if all the water goes out, then it will again increase.
Yes, sir. Yes.
So now they are not given that option. So we should go with D. Correct?
Yes, yes.
Clear now? Understood?
Yes, sir.
Done. Okay. Shall we proceed or shall we stop? What's the time? It's 8:30.